What is Nuclide notation? Nuclide notation is the shorthand way in which chemists represent the information about an atom. We find the chemical symbol on page 6 of the data booklet, and the position of this element is known as the atomic number, which can also be found on page 6, which is equal to the number of protons which are found inside the nucleus. The mass number is the number of protons and neutrons, which can be found on page 7 or can be calculated when you are given the number of protons and neutrons. So let's take hydrogen. The chemical symbol for hydrogen is H. The atomic number is the position of the hydrogen in the periodic table, which is 1. Protons are positive, so have a 1 positive charge. If we use page 6 and write down the electron arrangement is 1, which means it's got 1 electron in the first electron energy level. If we've got 1 positive and 1 negative, it means that the overall charge is 0, which means that this is an atom. If we go to page 7, we can see that the mass number of hydrogen is 1. If we have protons plus neutrons, which is equal to 1, take away 1 proton, that means that we've got 0 neutrons. We always take away the atomic number from the mass number to calculate the number of neutrons. Let's take helium. Chemical symbol is He. The position is 2, which means it has 2 protons inside the nucleus which have a positive charge. The electron arrangement is 2, meaning that we have 2 electrons, one found at 12 o'clock and one found at 6 o'clock in the first energy level. If we've got 2 protons and 2 electrons, it means that the overall charge is 0, which means this is an atom. Using page 7 of the data booklet, we can find that the mass number is 4. 4 take away 2 tells us that we have 2 neutrons inside the nucleus. Lithium, the chemical symbol is Li. The atomic number is 3, which means we have 3 protons inside the nucleus which are positively charged. If we look up the electron arrangement for lithium, it tells us we have 2, 1. In the first energy level, we have 2 electrons, and in the second energy level, we have 1 electron. That gives us a total of 3 electrons. Electrons are negatively charged. If we have 3 positive, take away 3 negative, the overall charge is 0, which means we're looking at the atom. On page 7 of the data booklet, we find that the mass number of lithium is 7. 7 take away 3 tells us we've got 4 neutrons. Beryllium, the chemical symbol is Be. The atomic number is 4, which means we have 4 protons inside the nucleus. The electron arrangement is 2, 2. Which means in the first energy level we have 2 electrons, and in the second energy level we also have 2 electrons. 2 plus 2 gives us 4 electrons, and electrons have a negative charge. 4 positive take away 4 negative gives us a charge of 0, which means we're looking at the atom. Using page 7 of the data booklet, we look up the atomic mass, which is 9. 9 minus 4 gives us a total of 5 neutrons. Boron has the chemical symbol B. It's got an atomic number 5, which means it's got 5 protons that are found inside the nucleus. The electron arrangement of boron is 2, 3, which means in the first energy level we have 2 electrons, and in the second energy level we have 3 electrons. 2 plus 3 equals 5, so we've got 5 electrons which are negatively charged. 5 positive plus 5 negative gives us an overall charge of 0, which means we're looking at the atom. Using page 7 of the data booklet, if we look up the relative atomic mass of boron, it has a mass of 11. 11 minus 5 means we've got 6 neutrons. If you want to pause the video, you can have a go at carbon and nitrogen, and when you're ready, the answers will pop up on the screen. Carbon has the chemical symbol C. It has the atomic number 6, which means it's got 6 protons which can be found inside the nucleus. It has the electron arrangement 2, 4, which means in the first energy level it has 2 electrons, and in the second energy level it has 4 electrons. 2 plus 4 equals 6. It's got 6 electrons which are negatively charged. If I have 6 positive and 6 negative, it means that the overall charge is 0, which means I'm looking at the atom. Using page 7 of the data booklet, the relative atomic mass of carbon is 12. 12 minus 6 tells me that I have 6 neutrons. Nitrogen has the chemical symbol N. its atomic number is 7, which means it has 7 protons which are found inside the nucleus. The electron arrangement of nitrogen is 2,5, which means in the first energy level it has 2 electrons, and in the second energy level it has 5. Remember, they sit singly before doubling up. 2 plus 5 equals 7. That means we've got 7 electrons which are negatively charged. 7 positive plus 7 negative gives us an overall charge of 0, which means we're looking at the atom. Using page 7 of the data booklet, we look up the relative atomic mass of nitrogen, which is 14. 14 take away 7 gives us 7 neutrons. This past paper questions from the National 5, 2015, multiple choice 1. An atom has 26 protons, 26 electrons and 30 neutrons. The atom has. So we set up our Nuclide notation so that we can populate our protons, electrons and neutrons. If we've got 26 protons, which are positive, that means that the atomic number is 26. If we look up the element 26 in the periodic table, we can see that that's iron, which has the chemical symbol Fe. We've got 26 electrons which are negatively charged. Then if we've got 26 positive and 26 negative, it means that the overall charge is 0, which means we're looking at the atom. And again, in the question it already tells us we're looking at atoms. And in the next lesson we're going to be looking at Nuclide notation of ions. We're given 30 neutrons, so something minus 26 gives 30. If we reverse that and do the opposite, 30 plus 26 gives us 56. That means that the atomic number is 26 and the mass number is 56, so the correct answer to this is multiple choice answer A. This question's from the National 5, 2013 specimen, written 2B. Complete the table for the Nuclide notation of the bromine atom given. And what it wants you to do is calculate the number of protons and neutrons. So we're going to set up our P, E and N. The number of protons that we have is equal to the atomic number, which is 35. So we've got 35 positive. Because it tells us that it is an atom, there's no charge above the top right hand side of the bromine. We know that we would have 35 electrons, so the overall charge is 0, so we're focusing on the atom. We want to calculate the number of neutrons, so we do 79 minus 35, which gives us a total of 44 neutrons. This past paper questions from the National 5, 2014, written 1B part 1. Complete the table to show the number of each type of particle in this gold atom. So we set up our P, E and N. We can see that they want us to look up gold, so the chemical symbol for gold is Au. The position of that in the periodic table is 79, which means we have the same number of protons, so 79 positive, because protons are positively charged. As we are focusing on the atom, the key word there being gold atom, that means that the overall charge has to be 0, which means we also have 79 electrons. 79 positive plus 79 negative gives us an overall charge of 0. We can see that the mass number is given in the question as 197. 197 minus 79 gives us 118 neutrons.